right, good morning, everybody. I appreciate you guys taking some time to join us this morning at our session. My name is David Chang. I'm in business development at HelloSign. And I'm going to give you guys a really quick introduction, then I'm going to hand off the bulk of the presentation to Arian Solberg, who is on our development team and is also our lead Salesforce developer. So really quickly, for you guys who aren't familiar with HelloSign, we were founded in 2010. Our founders, Joseph Walla and Neil O'Mara, founded HelloSign while participants in the Y Combinator, and left the Y Combinator with some great investment from folks like Greylock and Reid Hoffman and Google Ventures. HelloSign, since that time, is one of the fastest growing e-signature companies in the market today. We actually reach over 43,000 paying customers today across 150 countries. A couple important milestones, just given all the growth in the e-signature market, and specifically with HelloSign. We have our 5 millionth end user customer sign up for HelloSign products and use HelloSign products. And then most recently in 2016, hired our first chief operating officer, Whitney Bauk. Previously, she was actually the CMO at Box, and prior to that, she was the EVP and GM of Enterprise at EMC. So why did Joseph and Neil want to move into e-signatures? Well, I think everyone here probably at some time or another has had to go through a contract signing process, and I think sort of like standing in line in the post office, it can be very painful. Manual, paper-intensive processes, the traditional print, sign, and scan, it can be incredibly expensive. It's expensive with regards to lost productivity, very inefficient processes, clerical error, lost documents. It's not, it's really not how you want to manage important documents and time-critical documents that need to be signed. So the mission of HelloSign when we started it, or when Joseph and Neil started it, was to make the process not only get it away from manual, but also make it electronic. And along with that, we wanted to make the whole document signing workflow as frictionless as possible, as seamless as possible, and as most efficient as possible. And the benefits span many different areas. First of all, faster time to get a contract signed, reduced costs associated with lower productivity and lost efficiency, and also stronger defensibility. You know where your documents are going to be. There's layer of visibility, transparency, and oftentimes your documents are synced back into a secure, safe cloud environment or DMS. So HelloSign goes to market today with two primary products. The first is our web application product, and this is one where you'd simply log into hellosign.com, upload your document for signature, send it out, get it back, and then sync it into whatever content management system you have. The second way we go to market, which is really how we differentiate from, I think, our competitors, is our API. HelloSign, there's a number of e-signature providers out there. We are really the only e-signature provider that is primarily focused on our API. Our API was developed by developers for developers, and the idea being, by being able to embed e-signature workflow into your software, your applications, you never have to jump now from interface to interface like you would with the web application product. So in effect, it makes it an even more seamless e-signature experience. Our API, we think, is, like I said, not only very developer friendly, it's feature rich, and it's very flexible with matching whatever integration criteria that you guys have. So one application of our API was actually our Salesforce application. It went live last week in the App Exchange, and we were able to leverage our API, and Arian's team was able to leverage the API to help build it out. So he's going to walk you through what you guys came here to see, which is his whole process with building our app.
Cool. Thanks, David. Good morning, everyone. So yeah. It was actually, this project was a lot of fun for me. It was our first entrance into the App Exchange, and having this great API made it really just a lot easier. So I'm gonna show you real quick just a screenshot of our app. Like David said, it's in the App Exchange. I want to show you this because this form, and if I had been more on my game, I might have turned this into a video, but this form is interactive, just like a lot of UIs out there today. There's a lot going on. You can click on the Add a Role button at the top, and you can add additional roles. You can click Add CC. You can get some CC fields. The merge fields in the middle, which pull in merge field data. The person here, they're creating a template. They can click on opportunity, contact, or account, and that'll switch the filter of the fields that are displaying. There's data validation that will happen if you try to click submit without filling everything out. So, you know, there's a lot going on, and choosing the best way to develop front-end technology is kind of can feel daunting at times. For any of you who have delved into that without spending a whole lot of time, it can be a little bit dizzying just because there's so many options out there. Our company, HelloSign, settled on React quite a while ago, and so I was fortunate enough to have some experience with React going into this project, and that's what I chose to use for the bulk of the UI work, and that's primarily what I'm going to be talking about today. Here are some tools that I used. On the left, React. I'm going to talk a little bit more about that. Redux is a programming pattern that's very popular with React, and it's also something I highly recommend. Cloud9 IDE is a browser-based IDE. Eclipse, you're probably familiar with. It's a little bit more old school, but it has its applications, and I'll talk about that. Atom is another IDE. It runs on your desktop, and Webpack and ngrok are kind of like developer tools. I'm going to talk about how these all fit together. So React, as I mentioned, it's a relatively new open source front-end library out of Facebook. It emphasizes one-way data binding and intuitive breakdown of data flows. The data is stored in props and state. State is essentially changeable by the user, and props are kind of like the initial data that the component is instantiated with. It doesn't change. You combine it, or frequently you combine it with the Redux pattern because React is more or less a view library. It doesn't really give you your model or your controller on the front end. So in that sense, it's a lot lighter weight than something like Angular or Ember or even Backbone. And that's actually part of why people really like it, because it's very lightweight, it's unopinionated, it lends itself well to the architecture that you want to implement. So it's great for modular plug and place if you want to, say, refactor your front end piecemeal and not just go whole hog like Angular the whole way. React is just great for that. Webpack, maybe some of you are familiar with Gulp, Grunt, these build tools. Webpack, we use Gulp, we use Grunt for a while, and we've now kind of done away with all of that. We've standardized on Webpack. It pretty much does everything. It's a complex tool, but I'm going to talk about some of the bare minimum stuff you might need for Webpack, but at a glance, it does ES6 compilation using the Babel transpilers. So, your ES6 next generation JavaScript code, which is super fun to write, easy to read, that's going to be transpiled down into a more compatible, widely compatible form of JavaScript that the multiple browsers will understand. It also does the minification and the bundling. It can create multiple bundles if you want. A bundle is essentially a giant closure. It namespaces everything, and when the browser loads, it invokes, and all of your app code runs inside that closure. And it runs a dev file watching web service, so it can bundle your code on the fly as you hit save. We're going to take advantage of that. It's got a ton of other options like CSS or SAS compilation and CoffeeScript and stuff like that. Here's an example Webpack module config file. You can see at the top we've got our 3 bundles that we define. These are for the 3 major HelloSign Salesforce flows: the send from template, create template, and the send doc. We've got the output, which has a variable -bundle.js, so it'll make 3 output files. You can see we're loading Babel there. So this is pretty much it. This is all I used. You don't have to have a crazy complicated Webpack config file to get, it's like a lot of other things. Like you can get 80% of what you need with only a small amount of the effort. And then of course you can optimize from there. ngrok, it's a tool that exposes a local web service on your dev machine to the outside world using a secure URL. It's temporary. You can fire it up at will. So I use this when Webpack is watching my dev files and it's creating those bundles on the fly. I'm going to show you how I did that. It's exposing those bundles to the outside world. If you also have a dev VM running, say, for example, a developer instance of your application. It has like an API you're interacting with. You can also expose that and have the Salesforce developer edition that you're working on hit your dev VM instead of your staging or your production. So that can be useful. Keep in mind that to expose multiple endpoints like that, you might need the Pro edition. And it was a little tricky. One other gotcha I just wanted to call out. HTTPS is a little bit of a pain in the butt with ngrok. I found it easier to kind of hack my VM to accept HTTP connections, just for development, just to kind of keep me moving forward. So. Atom is a really cool IDE. It's based on Electron, which is kind of a cross-platform desktop app framework. Microsoft Visual Studio Code uses the same technology. I found it really excels in front-end development. For those of you who have used Sublime, you'll feel right at home. A lot of the keyboard shortcuts are pretty much the same. Highly configurable, highly customizable. It has a great package management system, so a lot of people are contributing stuff all the time. Again, you can use it for multiple languages. I just find it's out of the box. It's more ready for front-end development. So that's where I did all of my front-end development. Cloud9, you might have heard of Cloud9. It's a total browser-based IDE. Very neat idea. I think this is the wave of the future. In a way, it can be closer to the code if your code is running in the cloud, like with Salesforce. It has native connections to Force.com. You can use it for free with one Force.com project, so you don't have to really even pay for it if you're just testing the waters there. It was recently acquired by Amazon, so that's validation of the space, and I found it was great for general Apex and Visualforce development. I first tried Eclipse, and I was like, this feels a little clunky. And then I tried Cloud9, and I liked a lot more what it had to offer, but we'll talk a little bit more about some of the cons of Cloud9 in a bit. So here's a package.json file. We used NPM, as you might imagine. It's pretty ubiquitous these days. On the dev dependency side there, you can see that I've basically got my Babel libraries. I've got Webpack and Webpack Server. On the right, Lodash, React, React Redux. Those two libraries, React Router and Redux Promise, I actually didn't use those. This is a pretty slimmed down package.json file. Again, you don't need a ton of stuff to really make some cool things work. React Router is a way of taking the URL and mapping components of it into your React app state. So you can do really neat things like deep link into a state of your app just via the URL and send that to people. And it can also hook into your browser's history, so you can do forward and back, and you're kind of clicking through the screens of your single page app. And again, this takes a little bit more work with something like React than with something like Angular, but it's because React is more customizable, and I think that contributes a lot to its power. This is not a talk on Redux or React, although I've already said a lot about it. I'm clearly excited about these two technologies. I just wanted to quickly speak to Redux because some people are still learning about it. It's talked about as a predictable state container for JavaScript Act. You can see on the right, let's start at the top. There's a certain state which it's a declarative app, right? So the state dictates what the UI displays to the user. The user initiates some kind of an action, maybe a trigger or something, which kicks off what's called an action. And an action has a payload, which is a bit of data, so maybe it's what the user typed into the field, for example. That would be the payload. And that gets passed through a reducer. A reducer is a pure function. It brings in the action and the payload, it compares it to the rest of the state, and it makes some decisions. And as the programmer, you're deciding what those decisions are. And it spits out a new version of the state. Now, one of the other defining principles of Redux is you don't ever mutate the state. You only make copies of it. This is something that the creator Dan Abramov has been pretty emphatic about. And you can do neat things like see a state string. It's kind of like event sourcing, if you guys are familiar with that. It's like you have the single source. The source of truth can always be reproduced by replaying the stream of events, and the events in these cases are the actions. So then the new state gets put in the store, and the UI updates, and the whole thing repeats. So here's how I bootstrapped my app. You recognize this as Apex code. I put a div there with an ID template form out, and in my bundle, I'm rendering React to that ID, the template form out, and I'm creating my store at the same time. I'm running ngrok at the same time, and I'm switching my bundle based on whether or not I'm development mode or staging or production. So here's an output panel in Apex. You'll recognize this as essentially conditional rendering. I have an asset endpoint variable that's been declared to my controller. If it's null, I'm pulling from a static resource, which has been, that bundle file was updated was included as a static resource in the managed package. If that asset endpoint, and this is a secure setting, I maybe should have said that, the developer can add in a URL to that asset endpoint secure setting, and that's going to then trigger the second conditional, which will spit out that URL, which is the ngrok URL. So you end up with this kind of branching. When you're in development mode, you have the asset endpoint URL set. It goes to ngrok. Otherwise, in production, it goes from the static resource. And I could see you putting in like a CDN as well if you don't want it to go from either one of those. It's really nice because you just make your changes, you save, you reload the page, and it's live. You can iterate extremely fast. I can't really imagine doing it any other way. Here's another tip. Your React app is probably going to have some initial state that you're going to want to load it with. In our case, I had like the origin object name that we were coming from, the edit URL action, so this was like our API endpoint, our client ID, and things like that. So what I do is I just put that in the DOM, in this HSign load state variable. Yeah, it's a global variable, but it's relatively tightly namespaced, so I'm not too concerned about that. And then right when we create our store, we dispatch an initial action called create template initial load. It pulls in that variable, and the reducer that's responsible for that action will essentially parse, like pick out all of those variables and load it into the state in just the way I want. And as soon as it comes up, the user sees the app. So this brings some interesting considerations. You can potentially take JavaScript functions into your React app as closures and pass them in that same way. So this could be, for example, kind of a neat way of passing in like action function scripts, which are tied directly, as you know, to the Apex controller. And then that way, essentially, the React app kind of has a direct conduit to the Apex controller. So I was kind of playing around with that. I didn't actually have to use it in my case. But another thought is that you might have other cases where you have something external to your app, but you want it to interact with the app state. This is a fairly common problem and kind of a quick solution, and if you can't think of any better way, this is totally workable. But in your component did mount lifecycle method, so whenever a React app mounts, it runs through these lifecycle methods. Component will mount, will receive props, did receive props. You can tie into any one of those, and in the did mount, I would just maybe set up like an event listener, and then at some later stage, you fire an event with some data, it catches that, and it pulls in the data, and it's in the React app context, and it can fire an action and do stuff with that data. So that's totally workable as well. All right. I'm going to spend just a few minutes talking about these 3 IDEs and tell you when I found which one's useful, because I actually ended up using all 3. And I don't think that's necessarily a bad thing. I think they're all good for different things. So Cloud9, I really liked its inline documentation, its code inspection, linting, error checking, had configurable snippets, had autocomplete, had Git integration. I didn't like that you couldn't subscribe only to a single package. It basically pulls in the whole developer edition, all of the code. And I didn't really find any good way to migrate code between organizations. You may have multiple organizations when you're developing a Salesforce app, and being able to like take all the code from one and like sync it to another is unfortunately like a fairly common thing. Maybe not fairly common, but it does come up. The best way that I found to do that was actually using Eclipse. So that's one thing that would make me leave Cloud9. And the test runner, and again, like Cloud9 is a great piece of technology. I encountered just a few bugs, like the test runner, for example, sometimes seemed to get out of sync. It would throw errors when there really weren't any, and that's frustrating because it makes you think something's wrong with your tests, and there's not. So, yeah, you know, again, like I wouldn't use it for running tests, but for general development of my Apex and my Visualforce code, I really like Cloud9. And I kind of already spoke to some of these, but you know, Eclipse, it's also good for general Apex dev work. No huge qualms there. You can subscribe to a single package, and it's fairly easy to transfer a full code base from one org to another, so I use it a lot for that. Again, it's not super great for running tests, and I felt like it was a little cumbersome to use and set up because it's kind of like this force.com plugin you have to install and get that working, and there's some quirks there. Sync to cloud after you save can take a few seconds. You know, if you're trying to iterate and reload and see your changes, that can be a little frustrating. And I didn't include the force.com developer tools like the developer console and things like that, but actually I use those as well. Atom. As I mentioned, it's great for front-end code, fast, familiar keyboard shortcuts, a great package management system. There's really no native force.com integration with Atom, so it's not really great for Apex or Visualforce code, and that's why I really only use it for front-end stuff. There's a few things that I couldn't quite figure out, or I wish I could improve if I were to spend some more time on this project. I really wish there was some kind of Git integration that worked across IDEs. And by the way, if any of these things up here, if you guys have any thoughts and you want to come talk to me after this, that would be awesome. But you know, making like regular code commits and keeping my repo in sync, that's important. And when I go you know, a week or more without doing that, that's concerning. So I would love it if there were, because I was using multiple IDEs, just one of them having a Git integration wasn't good enough. So I found myself kind of routinely just downloading all the data from Eclipse and then committing it and pushing it manually. And the front-end unit testing, I didn't spend a ton of time on. People in the React ecosystem like Karma. I think front-end tests are great. I totally recommend them. Salesforce obviously thinks highly of testing as they enforce the code coverage standard. If I were to go back, I would put in some front-end unit tests, probably using Karma. I didn't really do a ton of front-end form validation. I know some people use this library called React Form for that. You know, I've heard mixed things. Your mileage may vary. I definitely recommend checking it out. I've also had really great results with a pretty lightweight jQuery plugin called formvalidation.io. So I just kind of plug those guys, or that guy. I think it might be a single developer. But yeah, that works pretty well. Ajax calls with React. Kind of a little bit of a different beast altogether. I kind of skirted this issue, and my Ajax calls I actually made outside of the React app. I was in the fortunate situation where I wasn't really using a lot of the data coming back from Ajax. Our Ajax call kicked off an iframe, which is our embedded template flows, and so at that point the user is in the iframe doing stuff. But with Ajax and React, you know, anything asynchronous with React, you're kind of having to deal with multiple states. You have the like initiated state, the completed state, the error state, the canceled state, and you know, React will do things based on how you use those. So there's sagas, which are based on ES6 generators, and thunks, which is another way. I think it's more of a promise-based approach, but be prepared if you've got some Ajax stuff in your React app to spend a little bit of time figuring this out. It's not super trivial. Okay, so I just want to quick thank you first of all to all of you guys for coming out this morning, and all of the people on the Salesforce Stack Exchange site who are so helpful to me, and for any of you who have developed with Salesforce, maybe you've taken advantage of this resource. A few names that frequently answer my questions: Mohit, Eric, and SFDC Fox. Got to give them a quick shout out, and that's pretty much it. So I'm here to answer any questions. My colleague David, but thank you.
Excuse me. Question?
Yeah.
Did you do anything with, you know if there's any like React libraries that are built on the Lightning design system that sort of implement the SLDS components?
So with Lightning, you know, I kind of feel like Lightning, first of all, our app is not Lightning compatible yet. It's mainly because we rely on some JavaScript on a button somebody clicks, and that's not yet supported in Lightning, so we're going to have to figure out a way around that.
I'm not referring to Lightning components. I'm referring to the CSS framework, the Lightning design system.
I see.
In other words, you know,
Yeah.
building
Well,
a React app that's styled to fit in the Lightning experience and.
Right.
Okay.
I use Bootstrap CSS for this. I imagine you could use the Lightning CSS if you wanted to.
Okay. Right. I was just looking to see if you know, maybe there's like a library out there already of components rather than.
You know, if
having to
there's
write your own
not,
components.
maybe there should be. I think that's a good thought.
Okay.
So it might be something that yeah, it would definitely be worth looking into. I'm not sure.
Okay.
Cool. All right. Thanks, guys.